So, good morning. Thank you very much for being here today. My name is Nicolas. I'm a postdoctoral researcher at the University of Duisburg-Essen, and I have been working together with the people of CEA in the requirement engineering method and tool for PDP4E. I will just give a little bit of background on what is the situation we have and the innovation scenario we are facing at the moment. I mean, I think that Samuel and Victor described it quite properly. We are in a context in which we have legal frameworks such as the GDPR, and that introduces new challenges for requirement engineering. So basically, in privacy engineering, it passes that privacy should be like a main development aspect for software, and therefore it should be addressed from the very early stages of a system lifecycle, namely in a by design approach. The problem is that legal provisions in the GDPR and alike legal frameworks are expressed in a jargon which is alien to most of software developers. And on top of that, as opposed to many system requirements, these provisions are described in a very high level, namely that it leads to multiple interpretations and sometimes leads to ambiguous or contradictory software requirement. That being said, mapping legal provisions to system requirements is not always straightforward. So the main, that being said, the main goal or the aim of this of the requirement engineering method for PDP4E was to develop methods and tools that support the elicitation of privacy and data protection requirements in a systematically and structured way. And of course, make it computer aided to support the software engineers in this task. And for that, we want to align with the GDPR legal provisions and of course with the privacy and data protection standards such as the ISO 29100. And as you have seen in the slides from Samuel, we want this to be driven by privacy goals such as integrity, confidentiality, and transparency. Of course, we are not the first ones trying to introduce such methods or tools for privacy and data protection requirements. My former colleague at the university, René Mais, he introduced a method called ProPan, problem-based privacy analysis, which is a computer-aided method for privacy requirements engineering. And the main distinctive point is that it analyzes systematically the functional requirements of a system to be with regards to, say, to a set of privacy engineering protection goals. In ProPan, these goals are represented to taxonomies or high-level privacy requirements and meta models. And these taxonomies are derived from the legal frameworks that are relevant for the data controller and the data subject. In this case, it's pretty much GDPR oriented. And these taxonomies guide the method in the identification of critical points in the data flow of a system that is up to be developed. And these critical points, of course, are the ones that raise privacy concerns from the stakeholders' point of view. And another distinctive point of the method is that the representation of the system, as Victor said, systems can be represented in different ways using different diagrams, structures, or models. So this method follows the problem frame philosophy, which I will come back a little later in the presentation. So basically, the method fits the goals of the PDP4E project in the terms of requirement engineering, and the method can be divided in two stages or phases. Namely, on phase number one, privacy relevant information flows in the system to be are identified, and in phase number two, the privacy requirements are automatically generated out of the information which has been collected, defined, and analyzed. And for that, ProPan elaborates on a large number of software artifacts to document this privacy critical information on the system to be. For example, it describes the context, the different domains that are interacting in the system, stakeholders, third-party systems, events that flow across the systems, personal information, which information is available to which stakeholder, and so on. This is actually pretty much driven by the problem frame notation by Jackson, which actually his name is Michael. So Jackson introduces this philosophy on how systems should be modeled in the requirement stage of the development cycle. So mainly he says that, okay, a system will be operating in a context, and this context is composed by domains, interfaces between these domains. These domains exchange different phenomena like events, actions, messages, data, and stages. So this is the way in which systems are developed modeled under the Jackson philosophy. And as you can see, it's pretty much an event-oriented approach, which is used to specify requirements. Basically, you're saying, okay, causal or symbolic phenomena. Actually, you're meaning actions, data, or messages, but he uses this kind of jargon: causal, symbolic, biddable, lexical. It's basically referring to events that are exchanged across the system. This event-oriented approach of the problem frames, it's very interesting. It actually fulfills the purpose of modeling a system to be, and fulfills the purpose of requirement elicitation. However, because we are tackling a problem which has more to do with data, personal information, we need more data-oriented, I'd say, representations of the system, or at least we need to gather that information and document it so we can later on conduct a privacy analysis. And that's why ProPan introduces additional software artifacts to capture data, how data is aggregated, how data is related with each other, which data is available to whom, and introduces this three additional models, namely detailed stakeholder data flow diagram, available information diagram, and personal information diagram. So this is actually the way that ProPan bridges the gap with the Jackson philosophy in order to model the system and its data. As I mentioned in the previous slide, one of the main, let's say, contributions of the method itself, it's this collection of meta requirements or taxonomies, and these taxonomies are actually extracted from the body of the legal text, which is relevant, in this case the GDPR or also the ISO 29100 standard. And it's actually, the way it extracts these taxonomies is by analyzing the body of the regulation from using the lens of privacy engineering protection goals, namely linkability, transparency, internability, confidentiality, and so on. So if you want, for example, to generate transparency meta requirements, you will try to search for verbs or terms which are related to transparency, such as inform, notify, present, provide, and so on. And then you will try to collect all the articles that are referring to this kind of goal, and you will try to generate a taxonomy out of them. See how these provisions are related with each other. See how can they be broken down into what it looks like. So basically, you have a meta model that could, with different attributes that are referring to that specific goal and can be instantiated according to each particular software project. So in the second phase, so we just talked about how we will collect the relevant information. In this new phase, we will generate the requirements by analyzing the information that we have captured using these different artifacts. And basically, it's like we have a lot of information about the system, what it's doing, the domains that are composing the system, their relationships, and we can deduce different requirements using the taxonomy. So the taxonomy will guide in the deduction of the requirements. Taxonomies have a semantic template that can be instantiated for each particular project. And so, for example, if we want to generate an undetectability requirements for a stakeholder S regarding a counter stakeholder C, what we can do is to analyze the personal information diagram of S and the available information diagram of C, and a personal information P of the stakeholder S shall be undetectable for C when P is not available to C. So that sounds complicated, but basically is to look at these two diagrams, see what we have here and we don't have here, and then we instantiate that in the template. So basically, that's the game the taxonomies play in the derivation of the requirements. Because I was not involved in ProPan, and actually I come more from the human-computer interaction and an AI field, I was able to pinpoint, together with the help of Gabriel and the people at CEA, some flaws in ProPan. Basically, one of the first issues that arise in our discussions was, okay, does actually the taxonomies that are generated by ProPan guarantee that we have a full coverage of the legal framework we're addressing? And the answer is no. So that was the first flaw that we have identified. So we said, okay, we have to do something about that. And this is why we said, okay, maybe we need to generate these taxonomies in a more systematic way, which should not exclude what has been done so far, but we want to make sure that we achieve a certain level of coverage. And the other point was that we could identify a high amount of redundancy across the different ProPan diagrams and artifacts. For example, you will find in the different models that the attribute linkability appears several times and across different diagrams, and the same for the attribute origin. So we wanted to unify all that information, which is spread across like 10 different diagrams. I mean, just we have 1, 2, 3, 4, 5, 6, like 8 different diagrams that you need to make, and normally developers have problems with making one diagram. Imagine making 8 diagrams. So we said, okay, this is something that we have to take into consideration to create a more lightweight version of the method itself. And the other thing is that especially in the data flow that ProPan proposes for privacy engineering analysis, we see that everything is kind of like mixed up. You have stakeholders, data storages, processes, it's in terms of let's say context modeling, it's fine. The representation is adequate, but in terms of privacy analysis, we want something more structured to conduct the analysis in a more adequate way. So, long story short, we want to maintain the level of granularity which was achieved by the ProPan method, but we want to improve its interpretability and eliminate possible redundancies. So this is the method we came across along with, which is basically, you can say, you can see that the yellow boxes are extension points of the original method, and we have extended it basically with new privacy protection goals that might come, because now the landscape is quite clear, but it doesn't mean that in the years to come, new challenges and new goals will be introduced and new legal provisions will come. So we want to make sure that at least the whole framework for privacy requirement solicitation, allows an extension point. And on the other hand, we are preserving some of the ProPan artifacts, but we are changing a little bit the philosophy. We are moving from a more event-oriented approach to a more data-oriented approach. And this is actually the result of constant exchange of ideas and views between the University of Duisburg and CEA. We were about how can we harmonize the method according to the necessity of requirement engineering and the necessities of the PDP4E project, and reduce the overhead to optimize the method's applicability. And I will just summarize some of the most salient achievements so far. And this afternoon in the method, you will have the chance to see how we have achieved an implementation of this method. As I said, basically we managed to define a lightweight methodology for privacy and GDPR requirement engineering. We have managed to define the data structures that support such a methodology and reuse and adapt many of the ProPan code in this PDP4E RIG tool. We have managed to implement that, and we had actually managed to validate the tool using a case study with smart grids. Just to give you like a brief flavor on what I'm talking about, this is, for example, the meta model of the DFD that we are using for privacy analysis. Basically, you will find a DFD composed of data record requirements, data process requirements, and data flow requirements, meaning that we represent collection of data records that will be implemented in the future in some way and on a database, possibly. Activities that are performed over those records, and the exchange of information between them. And we have added some attributes to these elements of the data flow diagram, so we can conduct the proper analysis afterwards. So future plans and for the requirement tool is that yeah, we have managed to bridge partially the gap that we see between the accountability and the requirement engineering discipline. We have managed to update the methodology accordingly, but we still want to improve, for example, our graphical user interface, implement filter to help developers to navigate the model and navigate the requirements, and we continue on trying to achieve further coverage during the requirement generation phase of the method and the tool. So thank you very much.